everyone. Today we're going to discuss Paper 6 Probability and Statistic 2, February March 2025, 6-2. Let's begin with question number 1. For question number 1, the random variable x and y are independent distribution with n 44 and variance is 16, and for y the normally distributed with the mean 30 and the variance is 9 respectively. Find x minus y less than 15. So here, since they said x and y are normally distributed, so what I do, instead of x minus w or x minus y, I let my w is equivalent to x minus y. I introduce a new variable for me. Okay, so mean of w is going to be mean of x minus mean of y. We follow this. Okay, so it's going to be 44 minus 30 will be 14. Okay, whereas variance of w will be variance of x plus variance of y. Okay, please take note that even though here is negative, when we use variance we use plus, because if you still remember, it will be negative 1 square variance of y. It should be this way for variance. Okay, therefore it will be positive. So it's going to be 16 plus 9, it will be 25. Therefore probability x minus y less than 15, I can rewrite as probability w less than 15. Okay, where the w will be normally distributed with mean 14 and variance is 25. Okay, so it's going to be probability z score less than 15 minus 14 over cert 25. So it's going to be probability z score less than 0.2. Okay, so this one we can use the what we call normal distribution table. So maybe I can just put in my normal distribution values here. Okay, so just now I got z score less than 0.2. So here it's going to be 0.2, 0.20. Okay, so your final answer will be 0.5793. Okay, it's equal to 0.5793. So you can let your answer to be 0.5793 significant figure also can acceptable. Okay, that will be of question number 1. For question number 2, a researcher record time t taken by adults to complete a questionnaire. The results for a random sample of 60 adults who complete the questionnaire this year are summarized as below. So this is the thing. Find the unbiased estimate of ET and show the unbiased estimate of variance is this. Okay, we'll go for mean first. So unbiased mean is very straightforward. It's just going to be sum of t over n. So which will be 3678 over 60. So it's going to be 61.3. Whereas the variance formula, and this is a sample, okay, it's a sample, and they ask for the unbiased estimate. So variance of t, the formula is going to be n over n minus 1, sum of t square over n minus mean square. Okay, you can just substitute this into formula where variance of t is going to be, my n here is 60 over 59 multiply with 226,313.36 over 60 minus 61.3 square. Okay, so you calculate this, you will get 14.44. That's it. Okay, for B, in past the population mean time was 62.4. Test at 2% significant level whether the population mean for this year is less than 62.4. Okay, so here they are asking us to do the hypothesis testing, where here you need to come up with your H null and also H alternate. Okay, so you can write population mean, but normally I don't really prefer to write the long things, so I just make it mu. So mu is equivalent to 62.4 and mu is less than 62.4. Okay, or you can write population mean equal to 62.4 and population mean less than 62.4. It doesn't matter. Okay, now we go for the probability. Your z score smaller than, so just now we got my mean, the mean sample mean is 61.3, so it's going to be sample mean minus population mean over variance. Okay, variance over n t. Okay, so this is the formula. So it's going to be my sample mean from the above is 61.3 minus 62.4 divided with my variance just now is 14.4. Okay, so cert 14.44 over 60. Okay, so I'll get probability z score smaller than negative 2.242. Okay, so you can attempt to find the z score, or even you can attempt to find the probability of under this area, or you can find the z score for 2%. So I think that one is more easy for me compared to finding the z score for a probability area, because less than 2 is just, I can get directly 0.9. Okay, give me a second. Okay, so for just now here, for 2% significant level, so it's going to be here. So this is my 2%. Okay, and this region is a rejection region, and this is my acceptance region. Okay, means if my z score here falls on this line, then I'll reject my H null. If my z score falls on this line, then I will accept my H null. So let me find the z score for 2%. So for 2% will be 0.98. So for 0.98, 2 point this hey 0.98, I'm sorry, 0.98. 979798. Yeah, this one. So with 2. So it's going to be 2.054. Okay. So my critical value here will be negative. My critical value will be negative 2.054. Okay. So based on my graph on top just now, I just write in this way. So this is my negative 2.054, and this part is my rejection region. Okay, so negative 2.24 will be somewhere here, is somewhere here. So this shows that it falls in a rejection region. So we're going to reject H null. Okay, which means you need to explain your word. Okay, so it shows there is a sufficient evidence. There is sufficient evidence where the population mean time is less than, where, or to conclude, evidence to conclude the population mean time is less than 62.4. Okay, so you must know where is the rejection region. So some of you, maybe you can also use find the probability area. If the probability area is smaller than 2%, then we reject the H null. It's based on your understanding, it doesn't matter. Okay, for C, state with reason whether it's necessary to use central limit theorem in your answer in part B. So yes, so here we do use central limit theorem. Yes, the central limit theorem is necessary, and why? Why we need to use central limit theorem here is because we can see the question just now when we do, they does not mention whether it is normally distributed or not. You see, a researcher found that the questionnaire, and the completed questionnaire and summarized below. So there is no any single word mentioned it is normally distributed, and also the sample size is also large. It's more than 30. So we need to use central limit theorem, where you can say yes, it is necessary for use central limit theorem because the distribution of population is unknown. Or you can say the distribution of a population is not normally distributed. Also fine, it's can. Okay. Question number 3. The random variable x as a distribution Poisson 1.5. Find probability x more than 3 or more equal to 3. Sorry. So for probability x more equivalent to 3, since it is a Poisson distribution, so it's going to be like a endless. It's up to infinity. Okay, more than 3, it can be 3, 4, 5, 6, 7. It can be anything. Like probably more than 3 is going to be probability x equal to 3 plus probability x equal to 4 plus probability x equal to 5. Is endless. Okay, but what we know, the total probability or sum of the probability is always equivalent to 1. So what I can do, I can put 1 minus probability x less than 3. Okay, so because since it's a discrete, the x value must be start with 0, 1, 2, 3, 4, 5, and so on. So they ask for from 3 onwards. So total is 1. Okay, the total probability is always 1. So 1 minus this, you will get this. Okay, so it's going to be 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. Okay, so it's going to be 1 minus, I can fact the formula for Poisson distribution. You can refer to the formula sheet where probability x equal to x will be e power of negative lambda multiply with lambda power of x over x factorial. Okay, so it's going to be e power of lambda here is negative 1.5 multiply lambda is 1.5 power of 0 over 0 factorial plus e negative 1.5 times 1.5 power of 1 over 1 factorial plus e negative 1.5 1.5 power of 2 over 2 factorial. Okay, so you can press a calculator and you should get 0. Um, so you'll get 0.191. Okay, for B, find the probability that sum of the three independent values of x between 3 and 5 inclusive. So three independent value of x. So I let the sum of three independent value of x equal to w. So w is equivalent to x plus x plus x. So w will be 3x. Okay, therefore I can write the new Poisson. So the mean for the new Poisson will be 3, mean of the x is 1.5, which is equal to 4.5. So it will be 4.5. Okay, so this is the mean of the w. So they ask for probability between 3 w to 5. So it's going to be probability w equal to 3 plus probability w equal to 4 plus probability w equal to 5. So which is going to be e power of negative 4.5, 4.5 power of 3, 3 factorial plus 4.5 power of 4 over 4 factorial plus 4.5 power of 5 over 5 factorial. Okay, I just factorize the e power of negative lambda outside because you see for all the terms here there is a e negative 1.5. I just factorize out. It's easy for my calculation. Okay, so you can do that. So you just press this in your calculator and you should get 0.529. Okay, C, the sum of a large number n values denoted by x t using a suitable approximation, it will found that t more than 330. Okay, so this is a Poisson and this is a large number of n. So when I say large number of n, it should be approximated to the normal distribution. Okay, so it should be approximated to the normal distribution. So, and whenever you do the normal distribution, please make sure that you have to use continuity correction. Remember on that. So I just utilize this. So whenever I have a normal distribution, so Poisson with 1.5, and since I have a large number of n, okay, just now we used 3, right? So 3 times 1.5. So now one day when I have a large number of n, so it's going to be normal distributed with 1.5 n and 1.5 n. Okay, so it's going to be this, your mean and variance going to be the same. So here what I do, instead of p probability t more than 330 is equal to 0.0391, I change this into z score. So what I do, I just replace it, z score more than a is equivalent to 0.0391. So if I draw the normal distribution curve, so it should be a is here and this is the region. Okay, And since this one you cannot get directly from your table, so I changed to probability z score less than a will be 1 minus 0.0391, which will be 0.9609. So ultimately I'm finding this region. So this one will be 0.9609. Okay, and this one will be 0.0391. Okay, so this value I can find from the table. So let's go to table. Yeah. Okay, so 0.9609. So 0.9609. 9609. Okay, so 9608. So I add with 1. So 9609. So 1.761. Okay, so it's going to be your A is equal to 1.761. Correct? Yeah, I should highlight here. 6 and 1. Correct. Okay, 1.761. Okay, so and what is my A? My A is a standardized score. So my A will be x minus mean over standard deviation. So my x here, take note, this is my 330, but more than 330. So it's going to be a continuity correction. So 330.5 minus mean will be 1.5 n. Maybe for the time being, I just use lambda to make my calculation easier. I just use lambda first. Lambda over set lambda is equivalent to 1.761. So it's going to be lambda plus 1.761 set lambda minus 330.5 is equal to 0. So your what we call this is a quadratic equation. Okay, so you can rewrite this as cert lambda square in order to be get your lambda plus 1.761 cert lambda minus 330.5 equal to 0. So from here you can use your quadratic equation where your cert lambda is equal to negative b plus minus square root b square minus 4ac over 2a. Therefore, you will get your cert lambda is equivalent to 17.3205. Therefore, my lambda will be 299.997, where my lambda is 1.5 n. Therefore, 1.5 n equal to 299.997. So my n will be 200. Okay. So if you don't want to use the lambda, you can directly use 1.5 n. So I just don't want to have like too many complications into things. I just make it simple where I make it like a lambda. So if you don't want to see the lambda, you can use 1.5 n. It's fine. Okay. Okay, now question number 4a. The diagram shows the graph of probability density function with a random variable x. The graph of straight line OA, so 0a, 2b, where it's a positive, where elsewhere. Okay, show that b. Okay, what I know, since it is a probability density function, since they are probability density function, so the area under the graph, so the area under the graph, this must be equivalent to 1. Therefore, I use the trapezium formula 1 over 2 times base, which is 2, multiply the height a plus b is equal to 1. So 2 and 2 cancel. Therefore, b equal to 1 minus a. That's it. So you can use the total area under the graph to be that. Okay. And then For part 2, given that Ex equal to 1.2, find the value of A. So if I want to find Ex, the Ex idea will be your integral from 0 to 2 of your fx x fx dx. So I need to find my fx first. So my fx, if you notice, it is a straight line. So fx equal to mx plus c, where m you can use these two coordinate. So my m will be b minus a over 2. Okay, so my fx will be, my m is b minus a over 2x plus c is y-intercept, which is a. Okay, therefore my ex will be integral from 0 to 2 b minus a over 2x plus c, sorry, a multiply with x dx, because you see x multiply with fx. So it's going to be integral 0 to 2 b minus a over 2 x square plus ax dx. Okay, so you can integrate first if you want. Oh yeah, the answer is 1.2. So it's going to be b minus a over 6x cube plus ax square over 2. And remember, your b is equal to 1 minus a. You can substitute here. Okay, you can substitute your b equal to 1 minus a if you want. I will do later. Okay, so 1 minus a over 6 and x equal to 2 cube plus a 2 square over 2 minus 0, because when you substitute 0 you get 0 equal to 1.2. Okay, so it's going to be, when you simplify this you will get 4 over 3 minus 8 over 3 a plus 2a equal to 1.2. When I simplify this, I'll get 2 over 3a is equal to negative 2 over 15, and my a is equal to 1 over 5. Okay. So for this question, somehow you need to find the equation of the function. Okay, and you must know it is just a straight line. So you can represent this straight line y equal to mx plus c, where the idea to find the m is just a basic idea, y1 minus y2 over x1 minus x2. Okay, you can use the basic idea. Okay, and for c, you can use your a. It's just a y-intercept. Okay, that's it. Okay, now for B, a random variable t has a probability density function given by this. Find the value of c such that probability between negative c to c is 1 over 2. So in order to find the probability, you just integrate. So integrate negative c to c 1 over 2 cos t dt is equal to 1 over 2. That's it. Okay. So when we integrate, cos will get sine, so it will be 1 over 2 sine t negative c to c equal to 1 over 2. So sub in 1 over 2 sine c minus 1 over 2 sine negative c equal to 1 over 2. Okay, so remember, sine negative c equal to negative sine c. So it's going to be 1 over 2 sine c plus, because negative become positive, 1 over 2 sine c equal to 1 over 2. So sine c equal to 1 over 2, and c will be shift sine will be pi over 6. Okay, so you just need to know that this idea. If you don't know this idea, then you cannot solve this question. Okay, you must know that sine negative c equal to negative sine c. Okay, it's just like something maybe we can focus into the fourth quadrant. So let's say the what we call, this is my c. So sine negative c is equal to negative sine c, just like that. Okay. Okay, question number 5. Amir believed that 20% of the students at his college are left-handed. His friend believed that through proportion, okay, this is a proportion question. Okay, you can see this word, proportion P is less than 20%. Okay, it's less than 20%. So, okay, so it's proportion question, and P is less than Amir. Okay, they already give you H null P equal to 0.2, and alternate is H alternate P less than 0.2. If you decide to choose 35 students at random, 3 or fewer students have left-handed, then Amir will reject his belief. Okay, find the significant level of test. So here they just asked me to find the significant level. So here you can use the binomial distribution. So it's going to be binomial with the 35, and the probability is 0.2. So they want probability 3 or fewer. So probability x less than or equal to 3 is going to be probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3. Okay, so it's going to be 35c0 0.2. Okay, so 35c0 0.2 power of 0 0.8 power of 35 plus 35c1 0.2 power of 1 0.8 power of 34 plus 35c2 0.2 power of 2 0.8 power of 33 plus 35c3 3 0.2 power of 3 0.832. So you press this in your calculator, you should get 0.0605. Okay, okay, done. State the probability of type 1 error. So probability of type 1 error is actually equivalent to probability of rejection region. Okay, so you can directly take out from your part A. So it's going to be 0.0605. Okay, probability of type 1 error is equal to probability of rejection region. Okay, now for C, it is now given that the true value of P is 0.05. So now instead of 0.2 is going to be 0.05. Find the probability of type 2 error. So probability of type 2 error will be probability of acceptance region with new parameter. So here the new parameter is your 0.05. So we're going to find probability of acceptance regions will be x more than 3, okay, by using binomial 35 0.05. Okay, so it's going to be probability x more than 3 is equal to 1 minus probability x less or equal to 3. So it's going to be 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2 and probability x equal to 3. So which is going to be 1 minus, yeah, maybe I nudge this, 35C0, and now my new probability is 0.05. So it's going to be 0.05 power of 0, 0.95 power of 35 plus 35C1, 0.05 power of 1, 0.95 power of 34 plus 35C2, 0.05 power of 2, 0.95 power of 33 plus 35C3, 0.05 power of 3, 0.095 power of 32. Okay, you can press a calculator and you get 0.0958. So this will be your type 2 error. Okay. Okay, now let's go to question number 6. Okay, for question number 6, Nikki is investigating the views of students at her school about the school sport facilities. If she planned to give a survey to a sample of students, Nikki's friend said this survey is about sport facilities. So you should choose a sample of students from sports school team. State with reason whether you agree with Nikki's friend or not. So here I will say it. We cannot agree. Okay, we cannot agree with Nikki's friend idea. Why? It's because if they give the sports schools, so they might have a very good facilities. Okay, so and their opinion is not same as non-sports school students or like a normal students. So what I can say, the sports school students might not have same opinion as other students or normal school students. Okay, you can say this. Okay, Nikki chooses an appropriate random sample of 60 students. She finds that 45 of these things sport facilities is good. So this is actually a proportion. Okay, calculate an approximate 95% confidence interval for this proportion. Okay, this question is actually proportion. You can read from here itself. So the question is a proportion where you think the sports facilities are good. So here my P will be 45 over 60, which will be 3 over 4. Okay, or 0.75, doesn't matter. Okay, they want confidence interval. So my confidence interval will be, the formula I use is actually P plus minus Z score square root P Q over N. This is the formula. Okay, for confidence interval for the proportion. So here my P equal to 3 over 4 and Q will be 1 over 4. And for Z score, they said 95% of confidence interval. So I just draw a straight line here. So since they said 95% confidence interval, so it's going to be something like this. So this region is the 95%. Okay, but When you want to find the z score, you cannot find the z score for the in between. So what we do, so if this is 95%, we divide this into two. So here will be 5% and front 2.5. So here will be 2.5 and here will be 2.5. So when you want to find the z score or z score, it's going to be from here all the way down. So you're going to look for 0.975. Okay, you're going to look for 0.975. So I can use the another one with okay, I can use this. Oops. Why it looks so bad? Okay, sorry. Okay, so for 0.975, you can look here, the shortcut one, so which is 0.1.960. Okay, so my Z score, what's wrong? Okay, so my Z score will be 1.960. Is it correct? Yeah, 960. So 1.960. Okay, so you just substitute in. So my confidence interval will be, my P is 304 or 0.75, plus minus my Z score is 1.960, cert 0.75 times 0.25 over 60. Okay, so it's going to be, you can first plus, also sorry, first minus and you can plus. So your confidence interval will be 0.640 to 0.860. Okay, so how I get this is actually 0.75 minus 1.960, so 0.75 times 0.25 over 60, and for this will be 0.75 plus 1.960, cert 0.75 times 0.25 over 60. Okay, so this will be the confidence interval. Okay, for the different investigation, Nikki used another large sample with 99% of confidence interval, and the interval with X is confidence. So there are two confidence interval. The width of 99 is double the X. Okay, so the formula for the width of the confidence interval will be 2. The width of the confidence interval, the formula will be 2 Z cert PQ over N. This is the basic formula. So for 99%, so this will be 99%. So here and here will be 1%, so it's going to be 0.5, 0.5. Okay, so means I'm going to look for from here all the way down. So it's going to be 0.995. So I can go back here. 0.995 will be this here. 2.576. That's the score. Okay, so it's going to be the width will be for 99% confidence. The width will be 2 times 2576. 2.576 set 0.75 times 0.125 over n. I don't know. Okay, they say just a large random sample, that's it, so I don't know. Okay, similarly for x percentage, okay, the width is going to be 2 times, I don't know z score because I don't know what's the percentage here, so I don't know z score, so I just maintain as z score. But this thing remains the same, 0.75 times 0.25 over n. And they said the width of 99% is double the x, so means the maybe I just put width 1 width 2. Okay, so width 1 is equal to 2 times of width 2. So it's going to be 2 times 2.576 set 0.75 times 0.25 over n is equal to 2 times of width number 2. 2 times z times set 0.75 times 0.25 over n. So I can cancel this, cancel this, cancel this, cancel this. Therefore, 2.576 equal to 2z, where my z is equal to 1.288. Okay, and remember this one is actually here. Okay, it will be here 1.288. Okay, so we go back to the thing, we look for the 2.888. Sorry, 1.288, right? Yeah, 1.288. So will be 1.288. So 988899715. Okay. So my probability of this region will be 0.8997 plus 0.0015. Okay. So 0.8997 plus 0.0015 will be 0.9012. Okay. So this is this part from here to here. So I need to know this region so that I know where what is the here. Okay, the interval must be from here to here. So 1 minus 0.9012. So this region will be 0.0988 and this region will be 0.0988. Therefore, the center part will be 1 minus 0.9, sorry, 0.0988 minus 0.0988, which is going to be 0.8024. Therefore, my x is equal to 80.24, or you can give 80%, doesn't matter. Okay, so that's all from me. Thank you. So if you have any questions regarding paper 6, you can comment below the video. So I will try to explain as much as I can. Okay, so that's all from me. Thank you.